Hi class, this is Miss Mackenzie or Charity, whatever you want to call me. This section is on 10.3. We're going to skip 10.1 and 10.2, which is on like parallel lines, geometry. So like parallel lines and a transversal and a bunch of extra triangle ideas. So if you happen to see something that's in those topics in one of the reviews that I don't assign, just know we're skipping those ideas. So today we're going to cover just 10.3, which is going to start with polynomials and kind of the idea of those. So give me just a sec. I'm going to share my screen with you. Okay, so here is my PowerPoint. I'm going to walk through this, preferably on the first part here. And then make sure you know a couple formulas that are important and maybe give a couple examples. So the first thing is a polygon is any closed shape in a plane formed by 3 or more line segments. So the smallest polygon, if you have straight lines that you could make, is a triangle, okay? Because you have to have 3. If I only had 2 straight lines, that they wouldn't really make a shape. It'd be hard, okay? So I have to have at least 3, and that's a triangle. And I think, yeah. Here is like a little list, and this PowerPoint is available to you. So you could also pause, write this down. You could review the PowerPoint on your own. But we have our triangle. Then you should know most of these names, but quadrilateral is a 4-sided. Yes, we have squares, we have rectangles, rhombuses, and all sorts of different quadrilaterals. Same with triangles. We have acute, we have oblique. We aren't really focusing that much on all the different names. A little more on the quadrilaterals, but you should know the general name. Like this is a quadrilateral. Okay? 5 sides is a pentagon. 6 sides is our hexagon. 7 sides is our heptagon. And 8 sides is our octagon. 9 sides is a nonagon. Oh, and now I can't think of what 10 sides is. And then they get to a point where they're like 10 gone, 12 gone, 13 gone, because it's just, we don't have a name for all of them. So once you get such a big polygon, then we're going to go ahead and just call it like, I have a 14 gone. What does that mean? I have 14 sides that connect, that are all straight, that connect to make my shape. So these are the top 6 that we usually talk about. The other idea is a regular polygon. This is really important because it's part of your homework, but it says that all the sides and the angle measures are the same. So flipping back, so that's a regular polygon. Flipping back, if I look, these 3 angles look the same and the sides all look the same. Same with this one. And if you are a regular quadrilateral, you are a square. And then these are all pretty, all the angles are the same, all the sides, and same with all of these. So every picture here is a regular polygon because they all have the same length of sides and the same angle length. So again, that's regular. Okay, the last concept on here is a perimeter. Most of us have seen perimeter before. It's like, I want to take a walk around the outside of my property. How far am I walking? Right? So it's around your whole shape, perimeter, around whatever shape we're at. Okay, so then we're going to go into, well, let me show one other thing over here real quick. Okay, so this is part of the other section. So I want to bring up our classifications of our triangles. We're going to classify our quadrilaterals, so I would like to also have you classify your triangles. A little better angle. Go maybe. Okay, so if I'm looking at this, now I don't remember how to make it zoom in. Oh well, it is what it is. So if we look, if our triangle has 3 angles that are less than 90 degrees, we call it acute angle. So I always think it's a cute little angle, right? All the angles are less than 90. If you have one 90-degree angle, what would you call it? A right triangle. Literally, the other ones can't be 90, or you're going to have like part of a rectangle missing a side. Then the last big one with our angles is obtuse. If it's an obtuse triangle, one angle like this one right here is bigger than 90. So these three classifications are by angles. So just looking at the angles, acute, right, or obtuse. Then we could actually classify a couple more things, and that would be isosceles has two angles and sides that are congruent. So isosceles has two sides and two angles congruent. And if you have two angles, those sides are congruent. If you have the sides, those angles are congruent. They go together. You have to have both, just by the way we would form it. So you might have done in geometry, like you got out your little compass and your protractor in high school, and you might have actually drawn, why is this? Well, no matter how I draw those sides the same length, those angles will be the same, or vice versa. The equilateral triangle means all the sides are the same length, equilateral. The other word is also equal angular, meaning all the angles are the same. So it doesn't necessarily have to go with triangle either. Equilateral means all sides. Equal angular means all angles. Okay, scalene means no sides. So these classifications are all by sides. So all the sides are the same. None of them are the same, and two of them are the same. So I wanted to bring up those triangle classifications because I think it's important to understand, especially the right triangle. Okay. Another one that you can kind of see up here is that the sum of the triangle's angles are 180 degrees. So all three angles always will add to 180, no matter what. The other thing that you can see really small right here is Pythagoras' theorem. This might come up for you in real life, along with, I think there's one homework that might have a Pythagorean theorem. That is only with the right triangle, and it's just saying this hypotenuse, which is c squared, is equal to this side plus this side squared. So you can find a missing side of a triangle with this theorem. So again, you can find a missing side of a triangle with a squared plus b squared equals c squared. Okay, and again, I think I have an example of that here in a little bit, but here we are. We have our triangles. Okay, so minimize this. Then we're going to go into our characteristics of our quadrilaterals. Okay, so our quadrilaterals, our first one's parallelogram. So you could print this off, you could write it down in your notes and pause my video. But what is a parallelogram? It just means opposite sides are parallel. It also tells you opposite angles are congruent. Congruent just means equal in measure. So I throw that word at you. Rhombus, you have equal sides. So a rhombus, it's like you could take a square because a square is equal sides, but you might be able to squish that square so the angles don't have to stay 90 for a rhombus. Okay, it also looks kind of like a diamond. All right, so a rectangle, most of us know, but what are the rules for a rectangle? The rules are 90 degrees on all angles. Okay, it's also a parallelogram because opposite sides are parallel. That's it. That's our only rules for rectangle. Okay, and then for a square, you have opposite or all sides and all angles are congruent. This is our regular polygon for quadrilaterals. And the trapezoid has one pair of parallel lines like you see here. Okay, so what's kind of tricky is if I say I have a square, I can also call that square everything above it. Not the trapezoid doesn't work this way, but the other ones do. So a square also meets all the rules of a rectangle. It also meets all the rules of a rhombus and a parallelogram. So you could, because a square meets all of these, call it all those names, and a quadrilateral. A rectangle can not be called a rhombus because it doesn't necessarily have the same sides, but it can be called a parallelogram, okay, and a quadrilateral. So that gets a little tricky. So you have a couple tricky questions and you have to look at your chart and think through whether or not that square or that rectangle also meets other categories. Okay. So then, right, then we start to talk about perimeter. Guess I'll do theirs. I have another one written down over here that I kind of like better, but it's okay. So if I have perimeter of something, again, it's the outside of your shape, so you're going to add them up. This one has additional, which I like, which is our fencing is $5.25 per foot. Find the cost to enclose this field with fencing. All right, so it's 28 by 42. So what would we do? We take 42 plus 28 plus 42 plus 28, add up all those sides, and get the 140. You could use the formula they used as well, but perimeter is just adding up your sides. So you will have, let me pop over, you will have questions that look like this, where you have sides that are missing and you have to find all those sides to be able to add them all up. Okay, so you have to be able to think it might have a formula or it might not. Hang on just real quick. Allie, will you check if those chicken nuggets are done? Lunch from a baby. Make sure they're not burning. Okay, and so from here, oops, did they finish this one? Here we go. So they converted, oh yeah, then they converted this one. That's all right. I would like to show you the conversion, but I'll just talk about them. So we know it was 140 feet altogether, and they gave us, or yards, excuse me, let me go back. That was yards originally. And they gave us per foot for our cost. So we have to then convert, do a conversion, which we've already learned about, doing our conversion from yard to feet. Remember that you have to be careful of because it is a, oh no, that one's not, never mind. I was gonna lie. Okay, so we're gonna say we have this many yards and we know there's 3 feet in a yard, so these have to match, right? So that they cancel, and we would then basically times it by 3. So we get 420 feet. And that was kind of the lesson we went over right before our 3-week break. Okay, so then we know that's now per foot. So now we can use the $5.25 and times those to get the total money that this would cost. Okay, why do we learn perimeter? Why are we learning about quadrilaterals, polygons? Because they actually are used in real life. We can use the perimeter in real life. We can use those conversions as well in the middle of a real life problem. Okay, so this next kind of big idea is going to be, what else can we tell about these polygons? Okay. So what we can do is we know the angles of a triangle are going to add to 180 degrees. So we can use that idea, and we have this formula to find the degrees that any polygon's angles add to. Okay, so this formula is n -2 divided by 180. Pop over and show you something real fast over here. So think about it. If I have a rectangle, don't mind my beautiful drawing, usually I do better than that. How many triangles is this going to form? Well, 2. That's it. It's 2. So these would add to 180, and these would add to 180. So completely, they're going to have to add to a 360 degrees. So that idea of how many triangles fit inside this is kind of where this formula comes from. So again, it's going to say n number of sides minus 2 times 180. Well, this has 4 sides minus 2, right? So this would be 4 minus 2 times 180. So that's going to be 2 times 180, which we know is 360. So this formula is very important for figuring out the angles of a side there. Okay, so okay, so what if we had, okay, my daughter didn't hear me, hang on. Hey, Kenny, go get Allie to get the nuggets out of the oven before they burn. Reality of working from home and. Okay, so what if we had something, we'll call it problem 1. This is going to be problem 2. What if we had something like 1, 2, 3, 4, 5? Kind of looks like a sideways house. 5 sides. What do those angles add up to? I don't care if it's regular or what it is. What do those angles add up to? Not what each angle is specifically. That's different. What do these angles add up to? Well, we can look at it with our triangle idea. There's 3 triangles. Or we can think of, well, it's got 5 sides minus 2 times 180. Are those done? Okay, I'm recording, I don't want to stop. So 5 minus 2 is 3. So 3 times 180 is 3 times 180. Why can't I think of that? 540. And that's just the degrees of all the angles. All the angles. Okay. So what I can do with this information is if I have a regular 12 gone, what does each angle measure? Okay, so this is one I can't really draw. I can't use my little triangle trick. I can't see like there's 3 triangles, so 3 times 180. So what would I do for this? Well, it's got 12 sides and it's regular. That means every angle and every side is congruent or measures the same. So what we can do is we can use our formula for what all the angles add up to. And we can do that as 12 minus 2 times 180. Okay? They're all going to add up to this. So that's going to be 10 times 180, which is 1,800. Okay, then I know that if there's 12 sides, there's 12 angles, which you can look at all of your polygons and realize that. However many sides is how many angles you'll have. So if they're all equal and they all add to 1,800, then each angle will be that number that you get divided by the number of sides. So for this one, it's going to be this one divided by 12, the 1,800. So each angle is 150 degrees. So you could be asked, what do all the angles add up to? Bingo. Or on a regular polygon, you could be asked, well, what is each angle specifically going to be? And that's where you have to use that division. Okay, let's look at this one real quick, because this is kind of what I put on an exam. Let me see if I could get this to zoom in a little. Hold on just a sec. No, I don't know if I can. I think the only thing I could do is move this further. Okay, so if I have this, I'm trying to cover this bottom problem. Just a sec. Because I want us to just look at this one. Okay, so if I have this shape here and I just want to find the perimeter. So, and we kind of looked at this earlier, it has missing sides, and people tend to just add up the sides they see and not logically think through what would be the other sides. You have to have every single side to get your perimeter. So this one, you know, is going to have to be the 4 and the 3. So you can get this missing side as 7. Okay, so this side would be 7. What would be this side? Well, you have 2 so far, and it's 6 all the way across, so there's 4 left. Then you add up all the numbers you see, plus the 4 and 7 we just found, to get the perimeter of 26 centimeters. With perimeter, again, you're doing a length, you're adding lengths, so your unit, like centimeter, stays centimeter. It's not squared, it's not cubed. You're not talking area or volume. Okay? All right, so then, then we kind of go into tessellations and the idea of a tessellation. So let me bounce back in here because this video does pretty good. So what is a tessellation? Why are we learning this? A tessellation is tiling. Why would I learn about tiling? Well, in real life, we might want to tile something. So tiling is just the idea that at the vertex, at the corner, it has to be all the way around, and that's 360 degrees. So we know that we can take a square and it'll tile, and there'll be 4 of them meeting at that corner because 4 corners will add up to the 360. So tessellation is just tiling. What can you tile? Check out these examples. Now these ones kind of annoy me because they used more than one shape on every single thing, but you can do it with just one shape. Okay? So if we look at like this first one, it's got a 1, 2, 3, 4, 5, 6, 7, 8. Did I add that right? 2, 3. An octagon and a square. Okay, so they must meet right here at the vertex, which is the tip of my little weird arrow thing. That has to add to 360 degrees for that to happen. So those vertexes must add to 360 in order for something to tile. So your homework will ask, like, what are the shapes? What are they're regular? What does each angle add up to? Does it add to 360? Okay. So this is one that they're looking at, which I like because it's just one shape. That's the way I think the problems most of them I tried to assign, they don't have a lot of these questions, will be just one shape. But if I look at this, this is a 5-sided figure. So we have to do our 5 minus 2 times 180 to get what the whole inside of this pentagon, what each angle adds up to, and we have to divide it by 5 sides, 5 angles, to get what each degrees would equal, which is going to be 108. So each angle in this is going to be 108 degrees. So if I try to put 108 degrees together, it doesn't work because it doesn't add in any way to 360. So alone, a regular pentagon cannot tessellate. So it would then have to add to the 360. So there's an example. So another one is we just did one that was a 12-sided, right? And we said each angle was 150. Well, does 150 divide into 360? So 360 divided by 150 is 2.4. So no, it doesn't work either. So basically, you're figuring out each individual angle and seeing if you can add it up to 360. And I fit 3 angles there, 4 angles there, that kind of idea. All right, so this is my first lesson I'm doing for you via the online. Go back here. So watch this video, hopefully all the way to now. Take your notes and then complete your homework. I am gonna open up some office hours for y'all. Good luck.